Principle of moments, UTME Physics past questions 1985 to 1998. Let's get on with it. We've got a first question, UTME 1985, question number 11. We have in the figure 2 above, Mn is a light uniform meter rule pivoted at O, the 80 centimeter mark. A load of mass 3.0 kilogram is suspended on the rule at L, the 10 centimeters mark. If the rule is kept in equilibrium by a string Rp fixed at P and attached to the rule at R, the 20 centimeter mark, then the tension T in the string is. Now we've got this meter rule here, and we're told that the meter rule is Mn, and it is a light uniform meter rule. Now the key word we need to know here is that it is light. Now if it's light, that is telling us that we are not going to put into consideration the weight of the meter rule. That means the weight of the meter rule is going to be neglected. So anytime you see the word light, just know what that means. I'll still come to this later. Then we have is pivoted at O. We have that at the 80 centimeter mark. A load of 3 kg is suspended on the rule at L. So we know that if this load is suspended here, that implies that the weight here will be, and we know that weight is mg. So the mass is 3.0 kilograms times, if I assume 10 to be the acceleration due to gravity, we will be having 30 newtons. So that will be the weight hanging at the 10 centimeter mark. And if the rule is kept in equilibrium by this string Rp fixed at P here, is fixed at P here, and attached to the rule at R is attached to the rule at R, the 20 centimeter mark, then the tension in the string is. So how do we figure this out? We are going to be applying the principle of moment. We state that the algebraic sum of all the moments of all forces about a point is 0. Another way you could define it, or you could say it, is that the sum of anti-clockwise moments of all the forces about a point will be equal to the sum of clockwise moments of all the forces about the same point or axis. So what we'll do is this: we'll pick a point. Let's take this point to be our axis, or our axis of rotation, our point of rotation, or our axis of rotation. So it will eliminate the reaction force here. So if we take moment about this point, this force here is going to be having an anti-clockwise moment about this point, and instead of it thinking of getting the perpendicular distance here, because moment of a force is defined as force times the perpendicular distance of the line of action of the force to the axis of rotation, or point of or the point where we are taking moment about. So instead of you saying, oh, I need to get the perpendicular distance, they just resolve this force so that the line of action is going to have a perpendicular distance to that point where you are taking moment about. So if this one is right here and the tension T here is this, since it's having an angle of 30 degrees to the horizontal, now if we resolve it vertical, that is going to be T sine 30 degree. We will be having T sine 30 degree. So the perpendicular distance to that axis of rotation is going to be this distance here. And since here is the 8 centimeters mark and here is the 20 centimeters mark, the distance is 60. 80 minus 20, that's going to be 60, and this guy here will be having clockwise moments about this point. So what do we do? The principle of moment is that what? The sum of the moments about the point, in this case O, the sum of the moments is going to be equal to 0. So the sum of the moments is going to be equal to 0. So that is for that. So that means the anti-clockwise moments. The anti-clockwise moment here is 30 the force times the perpendicular distance. The perpendicular distance from here to that point will be the difference between these two marks, and that is going to be 80 minus 10 which will result to 70. So we've got this 70 equal to, then that is for the anti-clockwise movement. Then clockwise movement, the clockwise movement is t sine 30 degrees, which is the force, times the perpendicular distance, which is going to be 80 minus 20, and that is going to be 60 centimeter. So if we make t the subject formula, t is going to be equal to 30 times 70 divided by sine 30, which is 1/2, times 60. So 1/2 of 60, that is going to be 30. 30 will cancel 30, so everything will result to 70 Newton. And if we look at these options, our answer is not in the option. I'm pretty sure if you're in the exam hall, you take a good look again at your calculations and you see that there's nothing wrong with what you've done, then you can forge ahead. Don't pick anything, just leave it blank. Or now it's the computer based test, so you don't check anything, you leave your radio button or your checkbox, whichever one is, or whichever interface is presented to you, you leave it empty, then you move to the next question, just like we're going to do right here. UTME 1986 question number 9. We've got figure 2. A uniform metal rule QR is balanced on a knife edge, which is 55 centimeters from R. So we've got this uniform metal rule balanced on a knife edge. So let's say the knife edge is somewhere around here. This is where it is balanced, 55 centimeters from R. So from here to here is 55 centimeters. Now I said earlier that I was going to talk about this word uniform. Now the first keyword you got to understand is that whenever you're presented with the word light, it means the mass of the object will be neglected. Now whenever you see the word uniform, it means that the center of mass of the object is going to act at the geometrical center of the object. So whenever you see the word uniform, it means the center of gravity of the object will act at the geometric center of the body. So for a uniform meter rule, or for a meter rule is 100 centimeters. So from here to here is 100 centimeters. And since it's uniform, it implies that the weight of this mass is going to act in the middle here, right about here. So the weight of this object is going to act in the middle, and that means from here to here is going to be 50 centimeters. Likewise, from here to here will be 50 centimeters. So I've got that for that there. And we are told when a mass of 10 grams is hung at P, as shown in figure 2. So this here is the mass. The mass of the meter rule is, so we want to know the mass of the meter rule here. Now when this guy is hung at P, so it's always advisable to take moment about this point at the pivot point, the pivoted point. So we've got if we look at this is going to be having a clockwise moment about this point, this is going to be having anti-clockwise moment about this point. So what do? Sum of moments about that point is the algebraic sum of moments about that point is going to be 0. Another way you can think about that is clockwise moment. Sum of clockwise moment is going to be equal to sum of anti-clockwise moment. So sum of clockwise moment, for clockwise moment we've got W, that's the weight, times the distance. Since I know from here to here is 50 and from here to here is 55, that implies from here to here is going to be 5 centimeters. So we've got W times 5 centimeters is going to be equal to the other weight, which is 10 grams, times the perpendicular distance. Now since we know that from here to here is 50 centimeters and from here to here is 10 centimeters, that implies that from here to here is going to be 40 centimeters. So times 40. If we make W the subject of the formula, we're going to be having 400 divided by 5. and I'm pretty sure that will result to, is that 400? Sorry about that. From year to year is going to be 45 cm. My bad. So from year to year is going to be 45 cm, not 50 cm. It is from year to year that is going to be 50 cm. So from year to year is going to be 45 cm. And if from year to year is 10 cm, so that implies that from year to year is going to be 35 cm. So I'll have to take this guy off. So that's going to be 10 times 35 cm. So that's going to be 10 times 35 cm. So that will mean that we'll be having 35 times 10 divided by 5. 5 in here is 1, 5 in here is 7. So this times this, that is going to be 70 grams. So I have option C, which stands for correct. The next question, we've got UTME 1992, question number 7. A uniform light rod. Now, we told uniform light rod too, because the word light is used. That means we will be neglecting the weight of the rod. It's kept in horizontal equilibrium under the influence of 4 forces as shown above. Which of the following equations correctly represent the condition of equilibrium for the rod? So if we take a moment about this point, these guys will be having anti-clockwise moment about a point, while these guys will be having clockwise moment about that point, because they would tend to rotate in this direction. If these are the guys, these are the only guys acting on this side, that's the way. If how do you get to know the direction? Okay, imagine this force, and this force. The 3 forces are not there. It's only this force that is acting on the object. Now, how do you suppose this beam is gonna, or this rod is gonna rotate? Of course, it's gonna want to rotate in this way. So that is how you're gonna know how to figure out which direction the moment is going to act. So for that, we now have some of anti-clockwise moments. We have F sub 1 A, the perpendicular distance is A, then plus F sub 2, the perpendicular distance to that point is B, will be equal to sum of anti-clockwise moment, will be equal to sum of clockwise moment. For clockwise moment, we've got F sub 3 times C, F sub 3 times C, plus we've got F sub 4 times D. So we've got that. And if you look at these, of course, it's not going to be option A. Likewise, it's not going to be option B. Option C, no, there's no common factor. So I'm pretty sure if an exam or you want to go for this, but just so we simplify further, we will be having F sub 1 A plus F sub 2B. We bring this guy to the left hand side, we'll be having negative F sub 3C. Then bring this guy to the other side, that is going to be minus F sub 4D, will be equal to 0, since there is nothing left on this right hand side. So that looks like option D. UTME 1993, question number 12. Question number 12. In the diagram above, a lever of length 200 meters is used to lift a load of mass 180 kilograms. The pivot at P is 20 meters from the load. The pivot at P is 20 meters from the load. So definitely we would assume that the weight will be acting here, which is going to be 1800 Newton. Remember, from W equal to mg, assuming acceleration due to gravity is 10 newtons. What minimum force F must be applied at the end of the level? Now, the minimum force that will be applied there will be the force that will just balance this weight, because if this force don't balance this weight, then this guy is going to come down, then this guy is going to this other side of the beam is going to move up. So one minimum force must be applied at the end of this level. So the minimum force we have just have to balance this guy here. So what do we do? Since we know that from here to here is 200 meters, from here to here is 20 meters, that implies from here to here is going to be 180 meters. So if we take moment about this point, this guy is going to be anti-clockwise moment, this guy is going to be clockwise moment. So for clockwise moment, we have F times 180, the perpendicular distance of the line of action of the force to that axis of rotation there is 180 meters, will be equal to the clockwise moment, which will be 1800 times 20. F is going to be 1800 times 20 divided by 180. So this guy is going to cancel this, then I will have 10 times 20, which is going to be 200 Newton. And as you can see, that is option D. The next question, we've got UTME 1994, question number 8. The diagram above shows a uniform wood. Now the word uniform, that means the center of gravity is going to be at the geometric center of the body, of weight 200 Newton and length 50 meters. So this guy here is of length 50 meters. It is pivoted at one end, that is right here, and I'm pretty sure that is what we want to take moment about, and suspended by a cord at the other end at an angle of 30 degrees to the wood, as you can see here in the diagram. Calculate the tension in the cord if the wood is horizontal. Okay, the tension in the cord, let's call it T, and like I said earlier, just resolve this to the vertical, and that is going to be T sine 30. That's T sine 30. We have this guy here, T sine 30. If we resolve it to the vertical. Now then, if you take moment about this point, this guy will be having anti-clockwise moment about this point, while this guy will be having clockwise moment about this point. Now remember that this guy will be acting at the geometric center here, so that implies that from here to here is going to be 25 meters. And clockwise, okay, let me start with that. Anyhow you want it, you can start with whether clockwise or anti-clockwise. So anti-clockwise, T sine 30 times the perpendicular distance 50 will be equal to, for the clockwise, 200 newtons times 25. We make it the subject formula. That's going to be 200 times 25 divided by sine 30, that is 1/2 times 50. So we will be having 1/2 of 50, that's going to be 25, 25 cancels 25, that's going to be 200 newtons, which will be option D. The next question, we've got UTME 1997, question number 11. A uniform light beam, so it's a light beam, we're going to neglect the weight of the beam. Light beam XZ is hinged at X, it's hinged at X here and kept in equilibrium by the forces T and F as shown in the diagram above. So we've got this T and F here. If X O is 20 centimeters and OY is 30 centimeters, express T in terms of F, that means make T the subject formula. So what do? Now we'll go here, we'll resolve it to the vertical. So we have T sine 30 degrees, and this guy will be having a clockwise moment about X. If we take moment about that point, this guy will be having anti-clockwise moment about that point. So we'll be having T sine 30 degrees times the perpendicular distance equal to F times the perpendicular distance from here to here, that is going to be 50 centimeters. So we have 50 there. So T is going to be equal to F times 50 divided by 1/2 times 20, which is 1/2 of 20, that is 10, 10 in these, that is going to be 25. So T, I'm pretty sure I didn't make any mistake, because okay, we have F times F times 50, F times 50, then we have T sine 30 times 20, yes, so 1/2 of this, that is 10, 10 in this, that is going to be 5, so we have 5F, which is going to be option D. Wow, we're having option D here. Okay. UTME 1998, question number 8. A uniform meter rule weighing 0.5 Newton is to be pivoted on a knife edge at the 30 centimeters mark. So we've got a uniform meter rule. A meter rule is 100 centimeters. So we've got 100 centimeters. Now it's uniform. That implies the center of gravity will act at the geometric center, which is going to be 0.5 newtons. It's to be pivoted on the knife edge at the 30 centimeter mark. So here, 30 centimeters mark. We have 30 centimeters mark here. And where will a force of 2 Newton be placed from the pivots? From the pivot to balance the meter rule. Now, if you think about it, if you place the guy here, of course, it's going to turn over on the side. So I'm pretty sure you want to place that force of 2 Newton here, so it will kind of balance it, So you have anti-clockwise moment, balancing clockwise moment. So let's say the force 2 Newton is at a distance x from here. And from the way this question is turning out, I think this 30 centimeter is just trivial to this question. So since this is acting at the center, from here to here is 50 centimeter, that implies from here to here is 20 centimeters. So this guy is going to be clockwise, this guy is going to be anti-clockwise. So 2 times x is going to be equal to 0.5 times 20, and if you make x the subject formula, that is going to be 0.5 times 20 divided by 2, and 0.5 of 20, that is 10 divided by 2, that is going to be 5 centimeters, which is going to be option D. And I think that is the end of the video. I am your tutor SB Sanni. You can follow me on Twitter at SB Sanni. If you've got any question, allow me, I will respond to you. And you can also check our website www.sbelucidation.com. There you can download free past questions for your SSC and UTME, and I will leave a link in the description below. Thank you for watching. See you next time.